This massive structure, comparable to a six-story building, is not a factory. It is part of the powerful engine system of one of the world's largest LNG-powered container ships. From the inside, it is so vast that workers can easily walk through it. This enormous engine drives a giant propeller, whose height is nearly equal to a two-story house. Operating such a huge vessel requires an enormous amount of fuel, and for long ocean voyages, millions of liters of liquefied natural gas are stored on board. Most international trade in today's world is transported by sea. From small goods to heavy machinery, everything is shipped across oceans. While thousands of airplanes fly overhead, hundreds of thousands of cargo ships move through global sea routes. This vast transportation network keeps the global economy running. These next-generation container ships are not only massive in size, but also advanced in technology. Their length equals several football fields, their width spans dozens of meters, and their height rivals large buildings. Even without cargo, they weigh tens of thousands of tons. To construct such a vessel, thousands of steel plates are used. Each plate is cut with high-temperature laser systems and assembled into large blocks. These blocks are then lifted by giant cranes and joined together to form the full ship structure. Inside the ship are enormous cargo holds, where thousands of containers are stacked. Each container is locked using specialized securing systems to prevent movement during rough seas. Beneath the container deck lie fuel tanks, pipe networks, electrical systems, and multiple machinery rooms. The heart of the ship is its main engine. This multi-story high engine contains giant pistons that move up and down to generate power. These pistons connect to a massive crankshaft. As the crankshaft rotates, it transfers power to the propeller shaft. The propeller spins underwater, pushing the vessel forward. The entire process operates at relatively low speed, but produces immense torque, allowing the ship to move steadily through the ocean. The engine room contains countless pipes, valves, pumps, and monitoring systems. Engineers constantly track temperature, pressure, and fuel flow. If any abnormality occurs, adjustments are made immediately. When the engine starts, the entire structure vibrates slightly, but advanced damping systems control these movements. Ship control is handled from the command bridge located at the top. From here, the captain and navigation crew manage the vessel. Large digital displays, radar systems, GPS, and autopilot controls provide real-time information. These systems track surrounding ships, weather conditions, and navigation routes. Based on this data, the crew adjusts speed and direction. To steer such a massive vessel, a rudder and powerful bow thrusters are used. Bow thrusters are special propellers located near the front of the ship. They help rotate the vessel slowly, especially when maneuvering in narrow ports. Despite its enormous size, these systems allow precise control. The exterior of the ship is coated with special anti-corrosion paint. This paint protects the steel from saltwater and reduces friction with the sea. Lower friction means improved fuel efficiency and smoother travel across long distances. After construction is complete, the vessel undergoes sea trials. During these tests, engineers evaluate engine performance, navigation systems, braking response, and safety equipment. Every component is checked under real operating conditions. Once all tests are successfully completed, the ship is ready for commercial service. This giant vessel is more than just a large machine. It represents advanced engineering, careful planning, and the combined effort of thousands of workers. With cleaner fuel and modern systems, these megaships are shaping the future of global maritime transport.